Okay, Furuhashi, we're having some technical difficulties, so
Oh,
please
you're
give us a little time.
okay.
Okay,
Okay. I'm waiting.
thank
Yes.
you.
You're welcome. Thanks so much.
Hello, Furuhashi.
Yes.
So we have seen the presented slides, but we couldn't find your slide presentation actually. Do you have
Really?
it in your phone and can you present it in your phone?
Again, I paste at the chat space as a YouTube link. If you can show this YouTube video, that will be perfect.
Sorry, can you repeat it, please?
So I shared my YouTube videos link on chat space.
So can you give the YouTube link?
Yes,
Oh, okay.
please use this link. Yes, maybe please share. Yeah, that is better.
Okay. Salam. হ্যাঁ এই যে আসছে হুম হ্যাঁ ফুল সাউন্ড সাউন্ড বাড়ানো
Sorry. So I understand that some technical problem happened. But sorry. Actually, 8 minutes. I have to go to the departure counter. Sorry. I hope that problem will fix. But so I have to check my airplane.
is the video not visible? Taichi?
No. Yeah. No. Please control your side. I share
Okay.
YouTube. Okay. Please share my YouTube video on your
Yes.
side. Yes.
Hi, everyone.
Okay.
Thank
My
you.
name is Taichi. Thank you. Very good opportunity. But sorry, I cannot join to SOTM Asia. Cox Bazar. So because I'm moving to Brazil for the Hosoji Global Conference in Berlin. So anyway, today I would like to share about our idea and product. So the name is UNVT Portable, like this. This is a Raspberry Pi device, and so how to use this device for mapping. So I can share slide. Okay. Yes. So we are making offline web map server based on Raspberry Pi. That name is UNVT Portable. So and already we are implementing few years, and today I would like to share about the recent situation, UNVT Portable 2024. And so my name is Taichi, and my SNS account is a Map Concierge. If you find my face or account, so please follow me. And my main works is I'm working at the Aoyama Gakuin University in Tokyo. And many times I'm teaching about how to make digital map data based on OpenStreetMap, and how to use data with open source tools. And so another thing, so now this year, next year, I'm working as a visiting professor at the Politecnico di Milano in Italy now. So anyway, yeah, I'm collaborating with many universities and geospatial community too. So today's my talk related to OpenStreetMap, HOT, and the United Nations, and Dronebird. So just one thing. So about me. So this year, UN Mappers chose the Mapper of the month, August. So and now we are gathering with not only the students, so but also so we are the UN side and the other geospatial community. We can make more better data map data, mainly OpenStreetMap. And yes, my experience is I'm mapper since 2008, and already I mapped over 70 countries like this. And many times I'm using our own drone, and I can get the imagery, and we can calculate the 3D point cloud data. And so sometimes we can make 3D model data like this. So this is a Mapbox next new version. V3, and so we shared, and so Mapbox made a very good hyper detailed our campus 3D dimensional data. So and we shared some reference data. Anyway, so now we can make own data. Of course, OpenStreetMap too, drone too, and we can combine for some purposes. And today is my talk, so very short time. So I divided some information like this. So already I shared about me, and so I'm working with UN side, the organization, and the working project name is UN OpenJS Initiative, and mainly we are doing as working group 7. And so UN has many department and institute, and so now we are collaborating as a kind of initiative. So UN OpenJS Initiative, and UN has a lot of types of works, and so many works related to map data and geospatial information technology, and UN OpenJS Initiative can provide advanced technology, a new idea, new data. So we can connect and we can provide those mainly open data and open source tools. And so if you have interest, you can join to the UN OpenJS initiative on GitHub. So many times we shared about the idea and data tools, and mainly open source. And so the past OpenJS initiative, so some domain working group, so that initiative divided some domain working groups. And the first step, first version, so our activity related to the working group 7. So the short name is UNVT. UNVT means the United Nations Vector Tile Toolkit. So we are combining mainly the core technologies, vector tile technology based on the open source tool. And so, if you don't know the tile, so tile is very important. So the recent web mapping system working on the tiling system. So that imagery is a very important, easy. So for that understanding. So if you have the huge size of image data like the JPEG file, PNG file, or TIFF file, so satellite imagery or drone can get. And but so big data is so sometimes very slow, and the data transfer is not so good. But tile is a kind of pyramid structure. So that system can divide the zoom level, and so that especially so tiling system can split each tiles, and that's zoom level. So just one tile for that whole global on the Earth. So and if you want to zoom in, so the tiling data provided the 2x2 or more many number of tile data set for that high resolution. Anyway, so we can recently we can use raster tiles data, and now we are moving to vector tile too. So that depending on each zoom level. Anyway, so the tiling system is already, I think, very famous and very general standard protocol. And we can check some tools. And vector tiles specification, open standard data format and protocol is a Mapbox vector tiles specification is very popular now. And actually in this year, OpenSMAP Foundation so provided the official OpenSMAP vector data. So I confirmed, and already testing site is open. So yeah, congratulations, OpenSMAP official vector tile hosting begins this year. So let's back to our works. So even OpenJS initiative, latest data working group, domain working group. So our activity related working group 7. The short name is Smart Maps, included UNVT. So we changed, we combined another technology, not only vector tile. Anyway, core technology is the vector tile technology. And anyway, so if you have interest, so of course we are sharing a lot of information on the GitHub too. And so today I have to explain about the UNVT portable. So based on Raspberry Pi. So that project related as defined as Objective 3. And yes, people joining. And so what is UNVT portable? So main contributor is me and Shogo Hirasawa. So he was my student. And so UNVT portable can provide mainly a data hosting service based on Raspberry Pi. And UNVT. So UNVT means UN OpenJS initiative shared that advanced vector tile technology. And so that technology is supported by a lot of FOSS4G components, open source components. And we are providing the importing technology, producing, data making process, styling, hosting, storytelling, and optimizing. Anyway, so we dividing and we shared, we defined that tool is very useful for this activity or process. So, and UNVT Portable, we are targeting only hosting. So UNVT Portable can work as an offline situation without internet. That is very important. So purpose is, if natural disaster happened, so that situation is a crisis mapping situation. So if disaster happened, so immediately we can get drones imagery, and then so we can share the data on that local people. So and the end user can use own web browser, but that situation is available in offline situation, because UNVT portable device can become the local Wi-Fi network, and that is a mapping server, web map server. And of course, we can add the raster tile data, vector tile data into the UNVT portable device. And until last year, so we combined the web server as Apache web server, and we customized the Wi-Fi and network tools, and we combined the MapLibre for the hosting. But sometimes, so Raspberry Pi OS is updated now. And this year, so we changed the web Nginx as a web hosting server, and network managing system is a default setting as the name is Network Manager, very popular name. And of course, MapLibre we are using. And so our Raspberry Pi's use case is very easy. So if someone want to connect to our device, so just the QR code, and user can access via the local Wi-Fi. And after that, another QR code we can provide. And so user can access to our web map data with drone imagery or something. And yeah, this is a sample. So sorry, I cannot bring our device in the real venue. So, but anyway, so if you use our UNVT portable, so you can access as a local Wi-Fi, and you can open the MapLibre with drone imagery and vector tile data. So anyway, so if you want to try, you can use, and you can set the UNVT portable. So we shared the install manual and the tools on GitHub, and please join to our GitHub. And I have just 1 minute. So I want to share about our use case as a drone pad. So, and yeah, sometimes Asian countries have the natural disaster. So if natural disaster happened, so we can use a drone. So, and so, but drone's imagery is many times the data is a few gigabyte or 10 gigabyte of very big data. So, and also if we want to provide our data from internet, so sometimes, so we get the data, and after that we published on the net. But yeah, in Japan, so sometimes that power infrastructure and the internet connection destroyed by the earthquake or tsunami or something. So, and actually, so 2019 big typhoon attack to Japan. So this is a real photo from the disaster affected area. So there is no signal, so that is no power situation. We provided the data for the municipality side, but so yeah, the KML is better or something. So, but so Raspberry Pi is just one answer. So without the internet, we can provide using by the local Wi-Fi. Yes. So easy access for everyone. Yeah. If you have interest, so please join to our GitHub repository. Yes. Thank you so much.
Thank you. Okay. That's okay. Bye, everyone.
Shushma, can you hear us?
It's okay. Can I reject? Okay, so am I audible now?
Yes.
Okay. So I'll share my screen. Shall I start or wait for a few minutes? Shall I start or wait for a few more minutes?
Do you need few more minutes?
No, I can go now.
Okay.
Okay.
You can start in 1 or 2 minutes. Actually, we're in a time crunch, actually. So if you can start in 1 or 2 minutes, that would be great.
Yeah, I think I'll start now. I hope my screen is visible. So yeah. Okay. So, good morning, good afternoon, everyone. I hope you guys are having fun at SOTM Bangladesh. I'm missing you all. I am Sushma Gimire. I am a Jewish Spatial Data Analyst at Kathmandu Living Labs and a proud representative of OSM Nepal community. And I'm thrilled to be here at SOTM Asia, of course online, but yeah, it's always about attending, to discuss about the initiative that we had here in Nepal, which is leveraging volunteer GIS and UAV for urban rooftop farming using OpenStreetMap. This was conducted in Banepa municipality, which is one of the popular municipality nearby the capital city of Kathmandu. This project showcases how the geospatial technology, how the geospatial community, how the open mapping community can be engaged in addressing something as sensitive as climate resilience and urban heat island and contribute to the open mapping as well. So let's dive in. Before starting, I would like to thank Booster Grant Committee 2021 Open Mapping of Asia Pacific. I would like to express my gratitude to Geomatics Engineering Society, which is a club in Kathmandu University, for the assistance and continued support during the time of need. I'd also like to express my gratitude to Professor Dr. Resma, Associate Professor Dr. Resma Shrestha, Dr. Rehena Shrestha, and Naren Thapa for leading this project, supporting and guiding throughout the tenure of this project. So here's a quick roadmap of today's talk. First, I will discuss about the mapping problem and what is its significance in the mapping community. Then I will delve into the problem statement and objective. I will also introduce the concept of UAV and VGI and how it is a part of any kind of solution that you can derive using maps. I will also explain the workflow of UAV and VGI. I will be highlighting the tasks for green mapping, and we will finally explore the challenges and impact of this work. So let's start by understanding what actually the mapping problem is. So urban areas are rapidly evolving, as we all know, but the maps that are available to us in open source ecosystem often fail to keep up. So the three main issues that I would like to highlight now would be blurry and not so clear images. This makes the details very hard to trace, and our map often fails to keep up. It gives us the limited usability. And another one would be poor image quality means poor map updates, less validation frequency. And another one would be outdated maps means outdated action solutions and planning are disconnected from the ground realities. Let me give you example. This is one of the area from Nepal. This image how highlights how outdated and low resolution satellite imagery is available in OSM. So you would say this is one of the most popular area here in Nepal, which is also one of the UNESCO heritage site. This is Swayambhu area. It is also listed in UNESCO heritage site, and this is the one of the screenshot from JOSM that I took this morning, and it's available in History World Imagery. You would say try checking on Bing imagery. So let's check Bing imagery as well. So if you compare these two imagery, you will see the History imagery seems to be more clear but outdated. See at this portion, see in the right corner portion and the left portion, you will clearly see the Bing one is updated but not so clear, and the History one is not updated but looks quite clear. You would say try zooming in further and you might see some good features along the way. Let me show you. Further zooming does not improve the quality of the features that you will see in imagery. This is the highest zoom level available in the JOSM editor. So let me take you to the this imagery from the first zoom level. This is at 30-meter resolution, this is at 10-meter resolution, and this is at 5-meter resolution. At the highest level of imagery, you almost lose the details of the imagery, and it's very difficult to map the details. Especially I am talking about the urban details. Now let's look at the example from Manila or Dhaka, Bangladesh as well. I tried looking and surfing the imageries availability in this area as well, and this area were no better. The imagery were almost not so clear. The imagery were low resolution in these areas as well. Now, I would like to take you to another example of the imagery from another world. I would say I am saying another world because this is somewhere in the Europe, and you will see the imagery looks much better. Let's zoom further. You will see the details are clear, and actually you can see the green roof in this imagery as well. And the final zoom level, you will be clearly able to delineate the buildings, see the features in the rooftop as well. So I would like to say the details are actually clear. It's not that bad, and you can easily map using the reference of this imagery. So now let's come back to our point. My point here is the imagery, the challenge of being imagery outdated, the challenge of being imagery low resolution is not a global challenge. It's not a global problem. I repeat, it's not a global problem. It's just prominent in Asia region, the where we live. And this problem means reduced precision in urban mapping efforts. And the key question that we are trying to address here is how can we improve the mapping precision and make it relevant to the current urban trends as well, so that we will be able to capture what is happening in the urban areas as it's going on. So another problem that urban areas these days are facing is the less green space. And this is one of the global issue. The imagery one was not a global issue, but I will say not having the enough green space in our urban area is one of the global issue. and the global challenges that we are trying to address as a global community. There's space for parking, but there's not much space for greenery, I would say. The lack of green spaces also impacts environmental and social uh, aspects of our life as well. So, uh, in this context, various researchers have highlighted that in urban settlement, the rooftop farming can be one of the good option to restore the lost greenery, and this was where our mapping initiative was inspired. Our initiative was inspired. The rooftop farming being one of the most suggested solution for greenery restoration, and being if we are being able to mobilize the community, our VGI community, our mapping community, then I think then we thought it would be a great innovative solution, a way of approaching the urban problems that we are currently facing now. So the key question here is, how can we actually leverage the open mapping community for the climate resilience, maybe by uh, moderating them for mapping the status and potential of urban rooftop farming status in Nepal. So now we are not only looking for the solution of the precision mapping, we are also looking for the purposeful mapping. We are looking at how can we map with cause, and specifically how can we leverage the open mapping community, open mapping ecosystem for addressing these kind of climate resilience causes. And our idea was to go through the initiative like rooftop farming mapping solution. So our objectives have twofold. One would be map the current status of urban rooftop farming, and another would be identifying the feasibility and potential of rooftop farming using the adjusting geospatial technology. And we fully relied on open mapping, open ecosystem for the geospatial technology. So, but how can we achieve this? How can we leverage the open mapping geospatial ecosystem? How can we leverage the open source ecosystem? And how can we also engage the mapping community and address the climate challenges as well? So this was the question uh, that we were trying to find the answers for, and we figured out that we need to overcome the limitations like low resolution imagery that I previously showed you, that which was hindering us for the detail mapping. And we also had to overcome the limitations of outdated data by adopting some advanced technology, maybe UAV and other was the thing that we came up, and our solution proposed the intersection of UAV technology, open mapping platform, and the community engagement. This combination provided high resolution, timely data update while also fostering the open mapping community here in Nepal. So why UAV? UAV has significant advantages over the satellite data that is available in JOSM. The satellite data that is available in JOSM in our side of the region, I have showed you earlier, it's quite blurry, it's not updated at time, but when you incorporate the UAV idea into your project, then you will get high resolution imagery enabling the detailed mapping of rooftop and other smaller features and other detailed features as well. Similarly, it's always up to date, and the community also gets strengthened with the UAV concepts. So our idea was to give the makeover to OpenStreetMap using all of these concepts and all of these community initiatives. We were using open source ecosystem like OAM, ODM. We were using the editor like JOSM. I call it DOSM for my understanding. And we were also using UAV and VGI. I will go into these steps one by one later on. Our study area was Banepa municipality that as I explained you earlier, the UAV imagery were specifically captured in these green areas. This green area also tend to show the growing urbanization in the recent year. Uh, so our workflow was to start with community onboarding and training them, followed by UAV image acquisition and processing. And after that, we conducted remote mapping and field validation and ensured the accuracy. And finally, the map data was shared with the municipality, shared with the open data platform, and also used for making some useful analysis. So this is the phase one that I explained you earlier. We just gave training to our volunteers. We also collaborated with the local authority. And in the second phase, we captured the UAV images. UAV drone Mavic 2 Pro was used for capturing the images. These are some of the flight details. And we captured the imagery with 60% overlap, and we are able to get 3 centimeter of resolution now. And for the imagery processing and hosting, we use WebODM, which is the Open Drone Map Repository, one of the open source repository for processing the UAV imagery. And we used Open Aerial Map for hosting our aerial imagery, so that it could be downloaded in the editor and browsers. And in the third phase, we trained our mapper for mapping guidelines for advanced validation. We also introduced the green mapping tags to our mappers, because we specifically wanted to trace the status and feasibility of urban rooftop farming. And for this, we focused on identifying the tags which would help us understand, is the roof green roof or not? What is the shape of the roof? What is the material the roof is made of? What is the existing practice in the roof? So this kind of things were considered for mapping, so that we could identify the status and feasibility of urban rooftop farming. So specifically, we use the following tags for our mapping. So these are the standard OSM tags that you can easily find in OSM wiki. And we were tracing, as I explained earlier, building. We were tracing the roof. We were tracing the type of roof, material of roof. We are also trying to understand, is there solar panel or water tanks or any other building parts in the rooftop, because that is where you want to access for your farming activities. We were also trying to see, is there any garden or any kind of farming being made or not. So these were the tags that we incorporated in our remote mapping using the UAV images. So in the third phase, we went to field for our validation and uploaded the data into OSM after the complete validation. And in the final phase, we prepared the maps, database, analysis reports, and also shared the data with OpenGIS special community and the local authority. Uh, so, sorry. So what we did was, we were trying to understand the rooftop farming status and feasibility. So for that, we considered 3 criteria using the multi-criteria decision analysis method, which is also called MCDA. We evaluated the buildings based on the criteria like water availability, gardening activity, and the type of roof that the building beholds. And this criteria were already mapped in our remote mapping sessions, and we would just extract those features, extract those attributes, and bring them in GIS and do the MCDA thing. And this was our criteria definition. And as a result, we saw about 19% of total households are currently engaged in rooftop farming in our study area. And out of the suitable household, 30% of buildings can be further use farming activities, and other 0.58 square kilometer of area remains available for expansion of farming. So this was the kind of analysis that we did. We also extracted the type of buildings, type of feasibility, and we also tried to visualize it in the map. So this is an Earth Engine map that we prepared. The green one shows the highest feasibility, and the red one shows the lower moderate feasibility, and thus the feasibility goes on decreasing. So this was the feasibility map that we prepared. And we also shared our drone imagery with the open aerial map that I told you earlier, we uploaded our drone imagery in Open Aerial Map repository, and it's available till the date. You can simply Google Open Aerial Map and search Banepa, and you will see this imagery, which was contributed through this initiative. And this was some of the map that we prepared after our initiative. So coming back to the challenges and lessons, we were after doing during the implementation of this initiative, we assessed that there are various challenges and lessons to be learned in this initiative. Implementing UAV and VGI for urban mapping was very difficult at the community level. That you would the community was not ready for taking the UAV. The local authority were not ready for giving the permission for flight. The open source ecosystem was also not ready in our analysis. In our understanding, the traditional mapping involves only these four steps, but when you incorporate the UAV into your traditional mapping, the extra steps are added on, and the community was not ready to understand this extra step. The volunteers needed extra training, advanced mapping training, and continuous monitoring so that we could assess them with how to map with UAV imageries. Similarly, the local authority were not very much flexible with the flight permission. They also had the limited capacity to maintain and update the UAV data further. And talking about the open source ecosystem, the Open Aerial Map, which was the repository where we were hosting our imagery, the learning curve was quite steep. It was very integrated to it was quite challenging to have mappers integrate the URL of Open Aerial Map into the JOSM and use that for imagery. Similarly, we if you Similarly, the Open Aerial Map had limited documentation back then. The hardware requirement to upload the imagery into Open Aerial repository was also quite high, and you would need some kind of technical expertise and good internet for integrating the Open Aerial Map into your project. Similarly, the Open Drone Map that we use for processing our UAV imageries had come with installation difficulties and complex setup and use. The learning curve for Open Drone Map was also very high. Similarly, Open Drone Map is till the date very resource intensive, and you cannot bulk process the imagery in Open Drone Map. And what we saw that the proprietary options that were available for processing the imagery were quite flexible and effortless than the available open source ecosystem options and solutions. Rather than that, what other can be the open source tools that can leverage the incorporation of UAV into the mapping ecosystem? We were looking at the flight planning tools. We were looking at if there is something like drone mapping tasking manager, which is a part of discussion nowadays. Is there any other tools that can help us to incorporate this kind of thing? So to sum up, I can say that this project demonstrated the promise of using UAV and VGI in urban mapping, but of course, it revealed the challenges that there are barriers to scaling this kind of project. Our pilot initiative has also been not been scaled up due to the resource intensive processes. Moving forward, what I believe as a part of this project initiator is that we must focus on capacity building, fostering capacity, and optimizing the resources that are available in open mapping ecosystem, open source ecosystem, so that UAV can be easily incorporated into VGI, and uh, we can get some strong solution. We can get some strong solution to face the to present the open mapping as a strong tool for addressing the local needs. So that was all for today. Thank you so much for attending my talk. If you have any questions, I would like to address them. And if we are not able to address them during this session, I'm happy to connect over the social media or email, and we can discuss it further. So thank you, everyone. Sorry, sorry, I couldn't hear you. Yeah, it's not. I cannot hear you still.
Hello?
Yeah, it's audible now.
Okay. So we will be going to our next presenter as we don't have any questions for you, Sushma. So
Yeah.
thank you for presenting, and we will be moving on to our next presenter.
Thank
Thank
you
you.
so much. Have fun, everyone. Bye bye.
I can continue. Is Faye Underl is present?
Hello, can you hear me?
Hello, Faye. How are you?
Hello. Good. How are you there?
Yes. Now I will be presenting your screen presentation, and if you could say next slide for if
Okay.
when we need to go to the next slide. Okay.
Okay.
And
Thank you.
I will request you to, if we can keep up the pace. Actually, we did have some technical difficulties, so we're a bit behind. So, thank you.
Okay.
Is the screen visible?
Not yet.
Not yet.
Not yet.
Okay. Can you share? Can you see my screen?
Um. Okay. It's now visible.
Okay.
Thank you so much.
Okay. Now I'm turning off my mic, and you can start.
Okay. Thank you. Hello, everyone. So, good day. Um, First of all, I would like to thank the organizers of State of the Map Asia 2024, the Bangladesh OpenStreetMap community, and also the Bangladesh Youth Mappers Network. You've been doing great work in hosting this year's State of the Map Asia conference. So, I'm excited to share with you today an initiative that's close to my heart. So, our journey in advancing OpenStreetMap through the validation stages via the Regional Validation Hub in the Philippines. So, my presentation will is just short, actually. So, I'll just go over it, and you can ask me later on after this. Okay, so next slide, please. So again, my name is Faye Andal, and I'm a volunteer of OpenStreetMap from Manila in the Philippines. And I love to work with open data such as OpenStreetMap, and I like using free and open source software like QGIS, Python, etc. And I've been also involved in different small groups in the Philippines, such as GeoLadies Philippines. I've been mentoring a local chapter of Youth Mappers. I've been also volunteering for HOT, and I also work for UPRI NOAA Center. Next slide, please. So this presentation will walk you through what the camp is all about, the rationale behind it, its journey, and our key takeaways from this experience. So next. So what is the Philippine camp about? Sorry, about the slide, I think it's not compatible with the PowerPoint format. But anyway, I'll just go over the talking points. So essentially, it's an effort to build the next wave of OpenStreetMap validators who are community members that who does not only contribute but also ensure data quality across the platform of OpenStreetMap. So it's actually a hands-on program where participants learn how to validate edits systematically with, of course, guidance from experienced mappers and validators. So it was actually inspired by the validation hub of Youth Mappers itself, and also by the humanitarian OpenStreetMap team, global and local validation team. So next slide. So our purpose was to actually design to help mappers to take the extra step, which is to validate and ensure that the quality of the maps we rely on are applicable. And our goal was quite ambitious because we want them to advance from beginners to intermediate to advanced level. So next slide. So we actually started around 48 people, and then what we wanted to have is all of them become advanced level of mappers. So next slide. Next slide, please. Okay, yeah. So the initiative was born out of the realization that registering on OpenStreetMap doesn't guarantee sustained commitment in contributing to OpenStreetMap data. And many contributors drop off after making edits or after participating a single mapathon. So leaving validation, which is an equally crucial part, neglected. And even when validation happens, it often relies on quantitative metrics rather than qualitative insights. So this is very apparent through the hot tasking manager because um, not all mappers can validate data unless you qualify to a certain level of mapping metrics. So that's a challenge that we wanted to address through this validation hub. So aside from that, validators also focus on the number of edits reviewed rather than the actual value or the quality of the data or the contributions being given by the mappers. So next, so that's why we launched this camp with high hopes. So we started with 40 students who showed the initial enthusiasm. But as we progressed, only 8 participants managed to finish the um, the program itself. And now let's talk about what worked and what didn't. So one of the key opportunities that we discovered was that, um, or the problem is that, next slide, sorry. I am already finished here. Okay, that. Okay, so only 8 participants were able to finish the whole program since it's quite long. The program is 4 sessions, actually 5, including the kickoff session. So it really requires time and commitment among the participants to be able to finish this. So to walk you through what we did, so next slide. Okay, so the itinerary of this camp was designed to immerse the participants in the OSM validation parts. So we introduced OpenStreetMap again as a refresher, especially to those who are beginners. And as you remember, there were 38 beginners who joined because they were very interested in advancing their mapping skills. So we started with OSM ID editor, and then as we go on, we discussed the different challenges in terms of OSM edits and how we can address those edits using the validation techniques of JOSM. And then we also covered some validation tools under the JOSM platform, and also invited Willie, who was the initial developer of OSM Cha. And then we covered some more advanced validation techniques so that the participants can be able to learn how to validate complicated data sets or edits. And then aside from that, we also had some mini quests to make the camp, since this is long session, more interesting. So we call them the secret side quests. So next. So these are the tools that we actually used when we were in the camp. So these were all remote. So we were just coordinating through Discord. So that's our main channel of communication. And then all of the materials, all of the PowerPoints and the demos were documented using Notion so that they can go over it even after the camp itself. And then, of course, the platform used were mainly JOSM, as it has the advanced tools for validation and their internal equipment, such as the computer and then their mouse. So next, let's talk about what actually worked and what didn't during the program. Next slide, please. So one of the key opportunities we discovered was the value of having an intentional program and then dedicated participants. So those who stuck with the camp showed noticeable growth, of course, in their skills because, as you know, 38 participants joined as beginner, and as we progress, they were able to learn how to validate even using ID editor and how to address common errors and warning using JOSN. So these were very important since that was the main intention of this program. However, challenges were inevitable here. So, for example, sustaining interest proved difficult. So since this is a very time-consuming project, energy levels of the participants, including me, waned and focus became inconsistent. So participants weren't able to attend some of the sessions, but still there were many participants showing dedication by attending all 4 sessions. And next slide, please. So reflecting on this program, we believe that this is quite a noble initiative. It's also similar to what the Youth Mappers Validation Hub and also the HOT validation teams were quite doing. So its success is actually requiring more than just enthusiasm or interest in validation, but also much importantly, it needs time and commitment as capital from the participants itself. And also, aside from those, it also highlighted the value of collaboration since a strong support network from trainees or the participants to the actual mentors and peers can make all the difference in sustaining the energy level and the focus of the participants in staying in this program and even after the program has ended. So in conclusion, the Validation Hub Philippine Camp reminded us of the incredible potential of the OpenSeatMap community when intentional programs are paired with committed efforts like what the participants has shown us here in this camp. So it also highlighted some gaps that we need to address both at the individual and also at the systemic levels so that we can push OpenStreetMap data quality forward. So I think that's the end of my presentation. So thank you, and I love to hear your thoughts or any or answer any questions that you may have about the camp. If we still have time later. But next slide. So if you're interested about what we do in Youth Mappers, you can go to our Facebook page. You can also visit our Twitter and Instagram to learn more about our programs. And if you have any questions, you can reach me, next slide please, through my social media account, Facebook or on X or Twitter. So thank you so much and have a great State of the Map Asia conference.
Anjar Akimullah, do you hear me?
Yes, I can hear you. Thank you so much.
Okay. Anjar Akimullah, are you hearing me? Anjar Akrimullah from Indonesia. I think. আচ্ছা আমি একটু কথা বলে দিই Ark Arjun, can you hear me?
Yeah, I can hear you.
We can start.
Cool.
Hello.
Can you hear me?
Yeah, I'm hearing you. Can we start now?
Yeah.
Okay, give me a second. I just play your slide.
Is it possible that I can share it?
Just give me a second.
The second last one.
Ark Arjun is just like us. We can put it up.
The second last.
Second last.
Is the slide visible?
Yes, but half is not. Can you press that full screen mode? The corner.
Hmm.
Yes. Thank you. Should we start?
Next slide. Okay.
Yeah. The first slide. Yes. Shall we start? Yeah. So, hi everyone. I'm Ark Arjun. Today, like everyone is speaking about OpenStreetMap, geodata, everything. I would like to speak a bit on the standards and importance of keeping the standards in geodata, which enables us to move from data silos to data sharing, which is actually open data. Next slide, please. Yeah. So, my name is Ark Arjun. I'm a software and open data enthusiast. One of the founding members of Open Data Kerala. Been mapping, volunteering OpenStreetMap till from 2012. I'm from I've been part of various some activities in Kerala, India, and been the hot voting member. Professionally, I'm a geospatial engineer, and I do write about geodata and open data in my blog. Next slide, please. Yeah, so this is a very sneak peek of what we are going to see today. Let's walk through what is geodata, then what is OGC standard, why does standard matters, what are the FAIR principles, what are open standards and benefits, and what are our challenges. Next slide, please. So, the standards of ISO standards, the data and information having an implicit or an explicit association with a location related to Earth is Earth data. Is there any problem?
No, it's okay.
So, what is geodata? So that's the standard definition of geodata. So in our daily life, we use a lot of geodata. On the right, in the blue, you can see the various geodata services or applications which we use. So what exactly is geodata? Geodata is any information that includes a spatial or a location-based component can be considered as geodata. It's not just only the features such as roads, buildings, forests, rivers alone. Even the abstract concepts of like population density, weather parameters, temperature, rainfall, all these are part of geodata when it has geographical or spatial components in it. And also the attributes of it. If you are considering the road name, width, etc., the lat longs, those are called the attributes. Those also can be considered as geodata. Next slide, please. So OGC standards. So what is OGC? Open Geospatial Consortium is an international voluntary organization who deals with the standards and develops and maintains the international standards for geospatial contents. Next slide, please. Next slide. Yeah. So what exactly are standards? So let's dive deep into that. Next slide. Standards are structured rules or formats or protocols to ensure that the geographical data is shared and stored in specific format and in a reliable and interoperable format. So to make an analogy, let me take the example of a road. So standards are like rules on the road for the drivers. So imagine if there is no road, traffic rules or any rules on the roads, it will be chaos, right? So the rules enables you to drive properly in a disciplined manner. It reduces the accidents and it also enables smooth movement of the traffic, right? Similarly, the geodata standards also is a set of format and rules which enables all the data storage and sharing of the geodata. Next slide. So, as all rules, standards are boring, right? Rules are boring, right? Nobody you want. There is no. Next slide, please. So why is it boring? Because it's fixed and plain. Next slide, please. And we don't have any surprises, right? Everything is written, everything is plain and simple, documented anything, right? But next slide, please. It is unimportant. As all rules, it is important. Next slide, please. So why does standard matters? So we live in a constant world where change is very constant and very fast, which is a very accelerating ecosystem. So standards become ever more important than even before in our previous times. They are very, very fast these days. They share a very common language, common platform to have the solutions of around geospatial seamlessly working. Next slide, please. So to make us understand how important the standards are, we all remember the Falcon 9 launch where the SpaceX launched the rocket to the space and the booster rocket returned back and back to the Earth. That was the first time, right? But it was almost very expensive, not only to SpaceX but to entire aviation industry in US. Why? Because the rocket, the entire space around the launch station was blocked for 3 hours. All the airlines was rounding, no signals, no green signals to move ahead. They were all held on the sky. So there was a lot of carbon emission, a lot of fuel emission, a huge loss. Why was this happening? The rockets was out in the rocket of the Falcon 9 was out to the space in 90 seconds, and after around 8 seconds, the booster rocket came back, and still the entire airspace was blocked for 3 hours, right? Because there was no system for the space system to communicate with the air traffic system, which enabled the movement of airplanes. So there was no communication or interoperability between these two systems. That caused a heavy loss to the entire industry, not just one company or a group of people. The entire industry, people lost hours on the transit, right? So So that important is a standard is. Next slide, please. So, moving to the page, so when we talk about standards, how can we ensure standards? So there are FAIR principles. FAIR principles are nothing that geodata should be findable, accessible, interoperable, and reusable. So various national policies emphasize the need of adoption of FAIR policy to boost the geospatial use. When we talk about geodata standards, this is the FAIR principle is the always being quoted, and the various national policies also do quote the FAIR principles. So let's see what FAIR principles are. Next slide, please. So let's take an analogy again here. It's not fair. There is no fair. So imagine you are new to the city. So you are all to a Cox's Bazaar. People from different parts of the world to attend the event. Then there are multiple bus services. There are managed by multiple agencies, maybe. So each agencies put up their standards, the bus routes, schedules in a different documentation formats, and there is no constant place where you can get everything in one go. Very difficult, right? You somehow being new to the place or want to plan your travels where nothing is possible. You don't know where the schedules are. You don't know the format are. You don't know where to reach out, right? And somehow even you managed to find one agency office, got the schedule from that, and decoded how they put their schedule. But the service is only half the way. After that, there is another agency running the schedule, and that agency have a different format of schedule. It's again difficult. You took both it will take hours for you to decode it, your travel plans, right? What, where, how, and somehow you figured and you prepared the plan and you succeeded. But if another person comes in, he has to go entire all these hustles to get that travel plan ready, right? So it's not fair, right? Next slide, please. So how can we can do the verification of this? All the transit agencies can document the schedules in any of the open standards like GTFS. GTFS is an open standard for general transit routes, and can be published the data can be published into the Open Data License. Once the data is available in Open Data License, OpenStreetMap volunteers can map it to the open data platforms like OpenStreetMap. Then any user can just simply use a navigation app, Organic Map or OSMAND or any mapping application. Just enter your start and endpoints, select the mode of transport. That's it. It shows the route, it shows the bus routes, right? And it's applicable to all. So the person 1 to person X or person N, it's the same principle, same way. The data is reusable, right? Not only that, we have the data there. The same route data can be used by the city administrator to optimize the bus routes. They can build dashboards. If there is any underserved routes, or if there is any more buses need to be provided in one route. All this can be brought into one platform and analyzed. And that's the beauty of standards is bringing to the table for solutioning, right? Next slide, please. So what exactly is FAIR policy? So FAIR, make the data findable. So this all is taken from the website called gofair.org. It's a standard website, like the standard organization where it publishes how that FAIR policy can be implemented in each and every data set. And each of these points have deeper examples and definitions provided. You can log into the website and look into that what exactly it means. I'm just briefly covering the things here. The first step is the reusing the data to find them. So if you need to reuse the data, you need to find the data, right? So the metadata and data, metadata is nothing but the data about data. So the metadata and data should be easy to find for both human and not only for human, and also that we are moving into a mission readable, like very faster world, all into CI/CD, continuous ingestion and continuous consumption, right? So in that mission also need to be everything what we publish in the format of data sets need to be readable by the mission automatically. Then only we can fast forward our processes. So that's what it means by findable of data. So there are 4 principles. I'm not going deeper into that. You can read into that. The second point of FAIR is accessible data. Once the user finds the data, now it is required that okay, you have find out the data where it is, but you don't have. What if you don't have the authorization to use the data? Again, it's not fair, right? So you need to have that open licenses which enables anyone to use the data sets as well. So that authority should be there, accessibility should be there. Not only just finding the data sets, the protocol should be open, free, and universally implemented. There are again multiple subpoints. You can find it again on the gofair.com. Next slide, please. Most important thing, once you have the data, once you have the accessibility to data, interoperability of data. So why is data interoperability? Nobody has the data, every data with us, right? We get data from multiple sources and build solution together. So like in the bus case, we need to have interoperability. Like in the rocket launch of the SpaceX, there was no interoperability. The space data and the space station was not talking to the aviation industry. So this interoperability is very much needed in a ecosystem like what we are in, the smart ecosystem, how we are. So the metadata use the vocabularies that follow the FAIR principles. The format should be accessible. It should be broadly like a very common standard language through which the protocol should be, and protocol and workflows should be common for everyone to analyze, store, and process the information. Right? Next slide, please. So when it is accessible, when it is findable, it is accessible. When it is findable, accessible, and interoperable, then the data becomes reusable, right? So the ultimate goal of FAIR is to optimize the reuse of the data, right? You don't have to produce the data every time. Each and every department of government, what we see is every department puts their own team, prepare their own data. There is no sharing of data, and the public money is being spent on that. If the one agency prepares the data, and if they shares commonly in open license in FAIR format, it's much easier for other departments and save money to use the same data sets, right? And the data become richer and richer all the time. So the ultimate goal is to reuse the data. But to reuse the data, it should be well documented. It should be accessible to all. It should be authorized for all. It should also be in certain format where everyone understands it, right? Next slide, please. So that's all about principles. Now, how can the FAIR principles become open standards and benefit? What are the benefits? When we talk about the open standards, there are proprietary standards as well, but we don't have any visibility to that. Only the company who is holding that or developed that has the visibility on how the data is being stored, how the data can be manipulated, and there is a lot of restrictions for the proprietary standards that restricts the entire use of data, not just the standards. The entire data is forbidden beyond a certain point. So that's why there comes the open standards, and we need to use open standards to facilitate constant communication across all the platforms in the industry, right? Next slide, please. So open standards, what are open standards? So open standards should be free from the cost, also free from restrictions to use. It should be free for all to use. There should not be any restrictions. it should be publicly documented in its entirely, because what it means, it should be entirely documented, publicly available to all, actively maintained by an individual organization whose business interests are not actually and would not reasonably give the appearance of being potential impacted by the constraints of standards. What this point means is, it should be maintained by some organization. It can be maintained. It's not should be. It can be maintained by an organization whose business is not actually with the standards. They should not be making their earnings by selling the standards or making the licenses, earning from these licenses. Because if that became the, then the constraint will be rising that if you need to use the standard, you need to pay the, so that the openness is not truly open, right? Then contains the structured releases, versions, change logs. So as we say, like it's ever growing. So it should continuously maintained. Releases should be there. Versions should be versions and change logs should be there, maintained very well, and has an open community of contributors, users, and transparent, inclusive governance should be there. So it should be very transparent, and every user should be able to use it. So all the standards which can be following these principles can be considered as open standards. Next slide, please. So why do we need open standards, right? Why do we need open standards? Next slide, please. Can we go to the full screen mode?
Yes, Arjun, we have to hurry a little bit. Can you hasten the pace?
Yeah, I think 2 or 3 slides more. That's it.
Okay, thank you.
Good. So don't we need to share that? We need to share the data, right? Next slide, please. So do we have all the data to solve the complex problem? No, right? We have an ecosystem. We share data. We don't have alone all the data. We how do we connect and communicate or become smart with our IoT devices? The smart city. How can we envision if we not share the data sets, right? Next slide, please. So the benefits of open standards are, we can save money. It propels the success. It accelerates the success. It increases the transparency. It increases the power of collaboration among different organizations and people. Next slide, please. So what are the challenges? The technology is ever changing and growing. So the problems to solve is also growing, right? Next slide, please. The challenges to use the open to standards are the lack of awareness and understanding among the users. The legacy systems and historic systems still follow the older proprietary standard systems. Resistance to change from organizations. Change management cost is high. Lack of enforcement or initiatives from the government or any other organizations. The cultural political barriers to change. Complexity of certain standards. For the same purpose, there will be multiple standards. We will be confused to use what standard, right? These are the standards, the challenges which we face for the following the standards. Next slide, please. Yeah. So that's all from my side. If there are any questions, I can answer, or else you can reach out to me via email or social media.
Thank you, Arjun. So we will be going to our next presenter. Yes, she She is Aksa Kalp, and she will be presenting the assessing the potential of rainwater harvesting through GIS and remote sensing techniques in combating urban flooding in Lahore, Pakistan. Aksa, are you there?
Yes.
Yes. Now I will share your presentation. So give me a little bit of time.
Sure. Hi, everyone.
Is the screen visible? Can you see my screen?
Yes, it's visible.
Okay. Then I will be presenting the slide, and you can
All right,
start.
sure. Thank you, Faiza. And thank you, State of the Map Asia team. There is some mic is open. I'm not sure. Can you please off the mic? All right.
Hello, Aksa. We cannot hear your voice.
Is it now? I'm audible. Am I audible now?
Yes, yes.
Yes, you are.
Yes, you can start.
All right. So here is the topic of my presentation is assessing the potential of rainwater harvesting through GIS and remote sensing techniques in combating urban flooding in Lahore, Pakistan. My name is Aksa Kalb and I'm PhD scholar in IGS NAS, Islamabad, Pakistan. And I'm working on the smart cities. So next slide, please. From the last 3 years, I'm working with the for promoting the OSM OpenStreet Mapping in Pakistan. The workshops I have conducted so far, and also taking into the integration into my PhD methodology as well. Then how to conduct this. Next, we have the catalog that how we are pursuing in the presentation one by one, like introduction part, research question. We have methodology, data collection, and proposals. So move on to the next slide, please, Faiza. Next slide. Okay, so as you all know, in the South Asian region, we have the problem of because of the climatic changes, we have millions of gallons of water, rainwater is wasted during the monsoon region. We have the problem of urban flooding. We are facing worldwide water challenges, drinking water, reducing the demand for drinking water, mitigating the negative effects of urban flooding. We can utilize out the solution rainwater harvesting. At the same time, we have the poor drainage infrastructure, which is for our urbanized cities. It's not going to tackle the heavy rainfall, resulting into the frequent flooding. More of that, we have the urbanization encroachment issues that's going to be affected our risk, burden on the infrastructure, at the same time increase the risk of flooding. And the next, we have the sewerage system as well, which needs to be upgraded because of the solid waste which we threw into the sewerage system. Next slide, please. So how we can say that we have the impacts as well. We have the lot of problem likewise because of the urban flooding. But at the same time, how we are going to tackle these issues, because day by day, as we see during our monsoon region, India, Pakistan, Bangladesh, we have the urban flooding issues. We have the power outages. We have the transportation system struck out. We have the soil erosion issues because of that environmental impact, diseases carrying mosquitoes and all these, the dengue, malaria, because of the flood, health hazards we have to tackle these challenges. So we need to think about nature-based solutions, and with the help of OpenStreet mapping, GIS analysis, and the tools like ODK, we can tackle these challenges. Next slide, please. Okay, so here is my case study area. That's Pakistan, and then we have the Punjab, and then we have the Lahore. So next slide, please. So the basic focus is on on this methodology. I also had won the funding last year 2023 from Women and GIS, and I came to know that I'm utilizes the land use, land cover calculated, and then I also done the data collected from the different departments, and at the same time I did the utilize out the Google Earth engine for calculating the precipitation type of for each UC of Lahore, Union Council of Lahore, and to calculate that where rainfall mostly occurs, where is that pattern of large areas where rainfall occurs. So it's like a open tools which we can utilize out by sitting in our homes and not going into the fields, and calculated the areas where mostly rain occurs. Then we have combined overlays all the layers, and then applied the AHY method to identify the flooded areas and urban elements which are mostly problematic for that. According with respect to that, by combining the people perception and the tools perception, then I came to know that which solutions we have to give. Next, please. Okay, so this is how we have find out the 5 years of data, precipitation data for each UC of Lahore, where high rainfall is occurring and where low rainfall is occurring. So most of the time, if you see the area, upper north area or at the right hand side, this is red area, highlights out that the most low of the rainfall occurs between 2018 till 2022 in these regions. That means that we have to tackle these areas at our first priority. And through Google Earth Engine, I just figure out that how to download the precipitation data, and no need to gather the data by going into the field and surveying the departments. So next slide, please. Okay, so there is a data of rainwater harvesting and recharge well. So I find out from the GPS points, we calculated from the departments we have. So two departments we have, we find out that where our existing recharge wells and water harvesting wells are present. So I located into them. Next slide, please. Thank you. So as you see that there are drainage pattern of Lahore is not well integrated. Because of that, there are many problems in the northern part of Lahore, and many challenges we have to face in the form of urban flooding, due to which we have many challenges in the monsoon region. And so that's why OpenStreet mapping and all that stuff came, and tools we are going to utilize to conduct this study. Next, please. So that's a flood validation point. So in Lahore, overall Lahore, we utilize out the ODK. As you all know, ODK is utilized for conducting our surveys, and that's there we can get that GPS points. So all over Lahore, from different people, from 500 plus surveys we have conducted through online, and we came to know these are the points where mostly water accumulated. So we have to identify them through collaborated with the people, and we just don't go into the field. Through ODK we can identify the GPS points. Next slide please. And then we did the AHP method, as I have shown into the methodology, that vulnerability analysis of urban flooded roads. Road network we have downloaded from the OSM, and that's where we identified that where most of the flooded roads are occurred, because communication struck out, people can't move from one place to another during the monsoon region. There are many water accumulated, and most of the time we have to face major damages, accidents, and many others where water burst out. Sometimes the houses, the infrastructure come down. So these things we have to tackle down with the help of our GIS tools and OSM tools. Next slide please. So at the end, we have also included the land use land cover that is going to be downloaded from the USGS Earth Explorer. And next slide, please. Okay, so flooded areas identification, flood risk assessment. So as I know, there is also in the legend highlighted that ponding sites through public perspective, where water most accumulated, we identified with the help of people. They have identified through that ODK tool, and then they indicated that these are the GPS points. We have to tackle these locations where mostly water accumulates. Next. So these are the pictures we have included during our surveys, that these are the roads that majorly affected during monsoon regions. Next slide, please. Like active bioswales in Lahore, where active bioswales are already present, so we are going to utilize them, and where we have to, by overlaying the previous slides, the previous layer I have generated through our study, we just overlay them, and then after that we are going to predict where next recharge wells can be installed, so that we can tackle the issues of urban flooding. Next. So these are the proposal for rainwater wells. It's basically the paper is under review and is existing and proposed rainwater wells. So here is the new existing through lots of, we can say, the ODK tools and OpenStreetMap data, and Google Earth Engine data. We combined out all these things, and we came to know that these are the points where we have to water mostly accumulated. So we have to propose these sites as recharge wells, so we can tackle the urban flooding issues, and it can be helpful for that methodological framework can be helpful for the Pakistan as well as for other regions of the South Asia. So I think that's next slide is last, I think. Yeah, thank you so much for giving me this opportunity to present on the state of the map Asia, and thank you for all your efforts you are doing for arranging such a huge event. I'm unable to join you guys as physically because of the some commitments, but let us see you next time. Thank you so much. Any queries you have, you can ask.
Hello. We were actually talking, but on mute. So thank you, Aksa, for your beautiful presentation. And
Thank you.
I think no anyone is there is no question actually. We
Okay.
have asked them. So thank you for your presentation. And now we will be going to our next presenter, Sharafat Islam Shohan. He will be presenting the topic enhancing rice cultivation in southeast hilly region of Bangladesh using AHP and GIS techniques. I will be requesting Sharafat Islam Shohan to present.
Yeah, thank you,
Now
Faizan.
I will be sharing my screen. So yeah. Is the screen presentable?
It's visible, but for your
Okay.
kind information for this paper, maybe we have two to present this, two speakers actually. For the
Okay.
first one, if Iftekhar Jaman started the presentation, then I will join later.
Okay.
So you can invite Iftekhar Jaman if there is no problem.
Okay. So please, Iftekhar Zaman, please start.
Thank you. Good afternoon, everyone. Thank you for being here today. My name is Iftekhar Jaman. I am delighted to present our research titled Enhancing Rice Cultivation in Southeast Hilly Region of Bangladesh using AHP and GIS techniques. This work was collaboratively undertaken by myself and my co-researcher, Mohammad Sharafat Islam. We both have been actively involved with field papers at IRS, Jahannagar University. Let's start the discussion to examine how these advanced tools can bring innovation to agricultural practice in hilly region of Bangladesh. Next slide, please. Breakdown of the study. Rice is not just a staple food in Bangladesh. It's essential for over 160 million of peoples. Beyond food security, rice cultivation supports rural livelihood by providing jobs and contributing to our national incomes. However, the sector faces several challenges such as low yields, land degradation, frequent floods, and the growing impact of climate change. Our study focuses on the Sylhet division located in the southeast hilly region of Bangladesh. This area is promising due to its fertile and land and favorable climate. And the study focuses on using geographic information systems combined with the analytical hierarchy process to address the challenges faced in rice cultivation in these unique geographical regions. This background sets the stage for exploring our methodology and findings in the next part of our presentations. Next slide, please. Our focus is Sylhet division located in the southeast part of Bangladesh. Sylhet is strategically bordered by 3 states of Seven Sisters in India. To the north, it shares a boundary with Meghalaya, and the east, Assam. The southern part shared with Tripura, while to the west, Sylhet is bordered by the districts of Netrokona and Kishoreganj in Bangladesh. As shown in the maps on the right, the Sylhet division is not only holds significant geographical importance, but also present a complex mix of terrain and climate, making it a key area of studying agricultural development and sustainability. Next slide, please. Our aim and objectives is the primary goal of this research is to identify the most suitable land for the rice cultivation in the southeast hill region of Bangladesh. To achieve these goals, we have outlined two key objectives. First one is to identify the rank key topographic and hydrological factors that influence rice cultivation. This is done using by analytical hierarchy process, which is a systematic and quantitative method for prioritizing multiple factors. And the second objective is to provide a comprehensive spatial map for suitable rice farming area within the select divisions. And these objectives guide our methodology and analyze which we will discuss further in the subsequent slides. Next slide, please. For now, we talk about our methodology log frame. For the first objectives, we have two research questions. First one is what are the key factors influencing rice cultivations, and the other one is how can the analytical hierarchy process used to rank their relative importance. And for the second objectives, our questions was how can spatial data and JS-based analysis identify the most suitable areas. We use our data and collect our data from different sources. Some of these are Landsat Imageries and DEM from United States Geographical Survey, CRU rainfall and temperature data, soil data from Bangladesh Agricultural Research Center, river data from local government engineering department of Bangladesh, and road data from OpenStreetMaps. For the first objectives, we use the different methods. First one is the normalized difference vegetation index for land cover map, interpolation for temperature and rainfall maps. For the other maps, we use topographic and hydrological analysis. And for the last and the second objectives, we use multi-criteria decision analysis methods. Thank you. This is my part. The next part will be present my co-speaker, Mohammad Sharafat Islam.
Thank you, Iftikhar. Thank you, OpenStreetMap. I am Mohammad Sharafat Islam. Now I'm going to present lift of the slides. As per our first objective, after literature review, we fixed 8 variables to prepare a rice suitability map in their soil map, temperature map, rainfall map, elevation map, soil map, distance from road map, distance from river map, and AOLC map we prepared. And then we scaled off is at analytical hierarchical process using some literature review knowledge and some experts' opinions. Then we got the weighted perimeters or weighted values of these variables. Next slide, please. For preparing this data, we have to classify the soil map into 5 classes. That's why there was more than 5 class soil. We have to combine it into 5 soil, and based on this suitability, as we know, the clay soils is most suitable for rice cultivation. That's why the acid basin clay soils here we represent as the most suitable soil for rice cultivation. Then other soils are brown hill soils also, the second or suitable, moderate suitable soils for this rice cultivation. And in this way, we also categorize the left other 3 soils. So next slide, please. In temperature map, we also know that 28 to 29, we also fixed that or reclassified that 28 to 29 degree Celsius temperature is best for rice cultivation. Actually, more than 25 degrees Celsius temperature is good for rice cultivation. That's why we fix it as the most suitable rice cultivation zones, and others are less than like that after analyzing some literatures. So in the next slide, please. In the next slide, we also show that rainfall map. As we all know that rainfall is very important for rice production, but over rainfall is also not good for rice cultivation. Actually, here we saw that yearly rainfall map of Sylhet division. You can see that there is 5 class, and the rainfall is started from 2,500 millimeter to 4,400 millimeters. As we all know that the precipitation in Sylhet region is mass. That's why we choose, after the literature review, we choose 2,500 to 2,900 is the most suitable zone for rice cultivation, and left of them are suitable zone, moderate suitable, less suitable zones, or very less suitable zones. In this way, in next map, please, next map, please. Next slide, please. In next maps, you can see that elevation map. As we all know that higher elevated land is not suitable for rice production, and the lower elevated land is suitable for rice cultivations. That's why we reclassify this elevation map on right is more suitable, or moderate suitable based on their elevation heights, elevations. So next slide, please. In slope map, you also can understand that slope is important for rice cultivation. The land which are more plain, this is most suitable for rice cultivation. That's why the less slope land we fixed as most suitable zone for rice cultivation, and the land which is more slope, which slope is steep, we considered that as very less suitable zone. According to this criteria, we reclassed this soil map for ASP. This next slide, please. Distance from river map. As we all know, river is a very important factor for cultivation, because flat plain is very flat plains conditions depends on rivers. As we all know, near the river, the land we called as ridge is elevated by sand, and we all know that sand is not suitable. That's why beside the river zones we fixed as a less suitable zone, and after 500 meters the land we recognized it, or we considered it as most suitable zone, because there the river water deposits the clay and silt soils, which is very suitable for rice cultivation. In this considered, we reclasses this distance from river map. Next slide, please. As we all know, distance from road map, already we my co-speaker said that we took this data from OpenStreetMap. After analysis this OpenStreetMap, we fixed that according to the distance, we fixed the scale, which place is more suitable zones and which place is less suitable zone. The next slide, please. And land use land cover map, as we all know that here we fixed the agricultural land for most suitable, and then we fixed the barren land for more moderate suitable zones, and the household area and river and forest areas are considered as less suitable or very low suitable zones. Next slide, please. Here you can see the analytical hierarchical process matrix, where some literature review and some expert opinions we input as the scale of importance of some parameters for rice cultivation. And after analyzing this, we maintain the every conditions of analytical hierarchical process and find that the soil type is most important or key factors for rice cultivations, and the importance of soil for rice cultivation among our variables is 34.7%, then temperature is 19.33%, rainfall is more than 14%, slope is 10%, then others are 7, 6, 3, and 4%. And after analyzing this, we are going to now our second objectives, in where we can represent you the soil suitability map. Next slide, please. In next, this rice suitability map is our result of second objective, in where we already know that Sylhet is the total area of Sylhet is around 12,000 square kilometer. Among them, we found that the result of this study found that most suitable zone for rice cultivation is 410 square kilometer, which is 3.57% of total land of this Sylhet division. And after that, we can see that 6,790 square kilometer is suitable for rice cultivation. This is the highest portion of this area which is suitable for rice cultivations, and it's cover 58 point more than 58%. And if we see that moderate suitable zones where it's found, the result found that 2,489 square kilometer is moderate suitable zone for rice cultivation. Actually, there, if the farmers try to cultivate the rice there, they can did it, but the result would not be good, and that's why this is moderate suitable. And the less suitable zones covered 14.89% of this total area of Sylhet division, and the very less suitable zone is more than 1%, which have no possibility to rice cultivation, because maybe this area or the highland or hilly area. That's why the map represents this. Among this different cultivated, you can see that the northern part of Sylhet division is moderately most suitable and suitable for rice cultivation. On the other hand, the southern part and southern eastern part is less suitable for rice cultivation. Next slide, please. Next slide, we just represent here the percentage of suitability land of Sylhet division. Here you can already know that the most part of the land is suitable for rice cultivation, and which is 59%, and moderate suitable is 22%, and most suitable is more than 3%, and others are not suitable for rice cultivation. So this result may be helpful for the farmers. Next slide, please. Here are some recommendations for the farmers, stakeholders, policymakers, and for future researchers. This map helps the farmers to choose the land to cultivate rice. The farmer can choose most suitable and suitable zone for rice cultivation, and they should avoid the other classes of land because they did not get proper results if they try to cultivate the other zones. And that farmer choose the other lands in another cropping systems. They can do another. They can cultivate another crops based on this crops criteria, and the future researcher can collaborate with the farmers to understand the real ground background of this data. And obviously, in future, the researcher should who will research in this topic, he should consider the climate resilient rice varieties, which types of rice actually grow well in this region, because there is temperature is high, slightly high, but that rainfall is more high. So high rainfall tolerant rice will be grow well in this area. And there is another issue, is climate change. As we all know, climate change has an impact on this areas, land suitability, lands, and the climatic conditions. So maybe it is an important parameter for the future researchers, and researcher can use the GIS-based decision support system for their research in future. Next slide, please. I am already. Next slide, please. Okay, thank you, everyone. I already finished my presentation here. If there is any question, I'm waiting for this. If anyone have question.
That's a problem.
Thank you, Sharafat Islam and Ittefaq Jaman for your nice presentation. So, do you guys have any question? So, thank you, Sharafat Islam and Ittefaq Jaman.
Thank you, everyone. Thank you.
Okay. Thank you, all of you, for presenting your interesting presentations. And this is the end of our day 1 virtual session. So thank you, everyone. And now we will be capturing a picture. So if you kindly please on your videos, open your videos so that we can take a picture if all of you are comfortable. So I would kindly request everyone to open your video camera so that we can take a picture. Okay, please wait a little while so that we can take the pictures. So everyone, please can we get a thumbs up for a successful virtual session? So please everyone, please give me a thumbs up. সবাই সবাই ক্যামেরার দিকে হ্যাঁ হ্যাঁ ক্যামেরার দিকে Okay, thank you everyone. So this is it. We are wrapping our day 1 virtual session. Thank you everyone. So we will be ending our session here. Thank you.
Thank you, everyone, once again.